What's up, guys? DragBoss Garage and Darin Morgan induction. Welcome. I'm glad you're all here. Now, that was a JC51. That's a 200-mile-an-hour ride, and that could be Ford's next pro stock interest in the future. Who knows? But I welcome you guys here. That engine was designed by Darin. There's a whole bunch of videos on that on our channel, and I'm going to add to that because it's got some good runs and it's pretty impressive. So I appreciate you guys being here. I thank my kids, Izzy and Elena, for allowing me to take time, Darin's family to allow him to have time, and you guys here that are spending some time with us. We already have about 37 people here, which is pretty good for 1 minute into the live chat. But we have Charles Servito. Thank you for being here, Charles. Gunnar from Iceland. Appreciate you being here. Michael, thanks for being here. And Mike Cranston from New Zealand. It's good to see you here. Tonight's episode is going to be on valve seat angles, throat tuning, 45 degrees to 60 degrees, seats, corresponding angles under the seat, and how various combinations utilize them, and what engine applications do the best with them. So it's kind of a whole thing on valve technology. Now, I will remind you guys that we do have a membership, Knowledge is Power, and we're going to have a live chat for members only, and that's next Saturday, the 6th, and that's at 6 p.m. So that's on the induction system and manifold tuning. So think about the membership there. Make sure you're liking, maybe even subscribe to this channel because there's a lot more coming at you. Darin, you got the show. We got almost 50 people in the house already, which is a great turnout.
Great.
You know, what'd you think about putting the stuff on 2 weeks early, putting the posts out there early? Do you think it helped?
Yeah, I think it did.
Okay. You guys comment about that. We try to get
a lot of people contacting me. So.
Okay, good deal.
Go ahead and give me full screen here.
Sure.
Tonight we're going to be talking about valve angles, throat tuning. First, I want to talk about seat cutting. If you look at a lot of the seat cutters out there, this right here is a Sunnin cutter. And this was a prototype that I made because if you notice the cutter's here and that cocks the cutter, there's no triangulation. The load-bearing area is underneath, so the whole thing tries to cock on the pilot and increases the wear. So back in, I think, like 2000, I had Sunnin make a special cutter body. And I think you can still order it, and here's the part number. And if you notice, it's extended. So now the load is directly across the pilot. It's not constantly trying to cock this on the pilot. And as that wears, it changes the angle. It turns a 55 into a 48 real quick.
Okay.
Also, chatter. When you're cutting a lot of angles, when these seat cutters, I mean, you're cutting over 1/4 of an inch of area. With the new ones and everything, this isn't a factor. But normal people, we have to use seat and guide machines like this. So you can make custom cutters, custom bodies, and mandrels to eliminate a lot of the chatter and a lot of the wear in your pilots. This right here is a vibration dampener, and it adds mass to this mandrel. So it prevents kickback and chatter. It took me about 5 different types to get it. These are 5/16 dowels in this brass body with oil in there, and then it's sealed on the top. And there's 20 thousandths clearance total. So as it tries to chatter, those will stop the chatter. And sometimes it'll come in and out, but it'll alleviate most of it. So I thought I'd show you that. So all you guys with seat and guide machines, now you can go start and play. Because a lot of the cutters that I'm going to show you cut a lot of material. And they have a tendency to push off and chatter. So you have to run them. The trick is to run them as slow as possible. Like on the 30 machine, you could run them at like 20 RPM, just as slow as possible. The other trick, another trick, is to break the surface tension, especially with copper beryllium alloy seats. Copper, phosphorus, bronze, whatever.
Mm-hmm.
Copper is really soft, and it's really hard to get these cutters to not ride up on the surface tension of whatever you're trying to use, oil and whatever, and they stop cutting. The trick here is to use Windex with ammonia D. It has to have ammonia D in it or it won't work. Dry it all out with like acetone or alcohol or whatever, and then spray it with WD or Windex with that ammonia D in there, and it will eliminate the surface tension, and it will just sit there and just powder. It'll just slowly, and at concentricity, it'll come in 1,000ths better.
Wow.
If you do that, especially when you're dealing with that much cutter body area. Let's see if I can blow this up. Nah, I can't. But I'll show you the cutters here. That's a ton of area to cut all at once, and it makes things a real pain in the ass.
You designed that
Anytime you use-
dampener? Sorry, Darin.
Excuse me?
You designed that dampener?
Yeah. That was the 5th iteration right there. That adds a ton of mass. I mean, that's 1/4 pound right there. So it prevents it from kicking back and setting up a harmonic and a chatter when you have that much mass. And if it does go into a little bit of chatter, those dowels in there with that oil will try to absorb it just a little bit. So now you know the pains that I go to try to get the seats concentric and cut. Because especially with beryllium alloys, my God, they lift that cutter and they try to ride up and you just can't get it to bite. The other thing is a lot of people will grind these flat. I'll go 0 to about -5 and actually change the rake on these cutters so to give it some bite. The other trick is slow, 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 slow. Surtees were awesome about this because the Siemens controller there, you could take it all the way down to 20 RPM, and a lot of the machines won't go that low. 40 RPM is about as low as you could go, and that makes it more difficult. But Windex with ammonia D, and use Windex with ammonia D with your reamers, your carbide reamers that you size the guides with. If you're not using it already and you use it, you're going to be shocked because that reamer will go right through there and you're going to go, holy crap. Instead of sitting there fighting it, and it'll just shoot right through. And it doubles the life of your reamer. Surface tension. Anytime you're trying to use oils, even the thinnest oils in the world, it doesn't work very well. You've got to cut the surface tension. Yeah, that's the top plate for it to seal it. So now we're going to talk about seats and throats and tuning up the Venturi section, which is what we're talking about. We're talking about a tuned variable Venturi. That's what it is.
Okay.
Because the throat and the chamber, of course, work together. You can't just lay a chamber back all willy-nilly and expect it to function properly. It has to be at the proper angle. Think of it as a Venturi. Think of the bowl as the convergent area. The Venturi is the throat of the Venturi, and the combustion chamber is the divergent region. All these areas, 1 inch below the seat and 1 inch above it, control 45% of this game. Okay? So where it comes off the top angle, that combustion chamber can band-aid too big of a throat, too slow of a throat. The back angles on the valve, you can band-aid too big of a throat if you have one, or you need one, because sometimes you're up against the valve, you have an engine that's undervalved by 50, 100 CFM, like ProMod engines or what have you. The chamber becomes really hypercritical at that point. In some engines, where you have too big a throat or a small valve and you're trying to squeeze everything out of it, you can enlarge the throat and bring the chamber in to control the pressure recovery, and help have the combustion chamber help. It's not really the proper way to do it, but it's a Band-Aid. We'll be talking about Band-Aids and things you can do to counteract a bad situation.
Yeah.
Because sometimes you get ahead in the shop that's already problematic. It doesn't have the right angles. They've blown the throat out. They've made it too big. It's misshapen. So you can use certain angles and back cuts to help Band-Aid those situations. This is a breakdown of the amount of control these areas have over the airflow into the engine. So up here, the further you get away from the valve, the less effect it has on the overall airflow going into the engine. As you approach the throat, it gets more and more critical. Between the combustion chamber and just about an inch before the short side, that's 75% of the game right there. This is the dynamics right here, this situation that control the flow curve and a lot of other aspects. And we'll go through why we use the seat angles we do for the different laybacks. This is a CFD. Red means high velocity. Yellow is the lowest velocity. Well, look where all the airspeed is. So think about what we're trying to do here. We are trying to turn the air around a valve at every lift increment efficiently and get the most airflow possible. We're tuning a high-speed area to turn air around the valve efficiently at all lifts. That's why I say it's a tuned variable Venturi. Now, I was just talking to Joel earlier because he wanted to talk. He talks a lot about this, and he goes into a lot of the higher end aspects of seat tuning and throat tuning. I'm not going to do that. I'm going to give you the baselines to work from. But when you're dealing with some real high-end cylinder heads that are up against the valve, meaning that valve itself is the restriction, you can do a lot of crazy stuff, and I'll show you that later on. Some of the really steep seats we use on Australian Pro Stock and Unlimited NA engines. It's not what you think, I'm sure. But seat tuning outside of these baselines, let's just say the baseline throat and valve angles we're discuss are baselines. They work perfectly across a broad range of engine combinations, cubic inches, disciplines of racing, RPM bands. If you follow the baseline rules I'm about to lay out, you're going to have good torque, good acceleration. Everything is going to work properly. If you veer off of this, is there power to be had? Absolutely. Absolutely. There's more than one way to skin a cat. I'm just going to kind of lay out a way that you can hit the nail on the head. Yeah, you might be leaving 20, 25 horsepower on the table, but that engine is going to do everything right. It's going to go out and accelerate. It's going to pull. It's going to pull fuel. It's not going to lean out, detonate. The induction is not going to be too slow and cause problems. So the system will make more power if you change this stuff. Question is, are you willing to push the limits and change the cam events, the induction system design, the exhaust system design, increase the engine speed, and all the other design factors to extract that increase in power? Because if you veer off of these baselines, that's what you're going to have to do. Because with an off-the-shelf cam, off-the-shelf ported manifolds, generally available cylinder heads, that's what we're talking about here. When you try to push 2.2, 2.5 horsepower per cubic inch, this shit goes out the window, and I'll show you how far it goes out the window. But then everything gets hypercritical. And now you're off into territory where it's no man's land. And you're playing around, you're playing with fire. Okay? And it's easy to go backwards. It's easy to kill power. It's easier to kill power than to make it. So these are the baseline figures. So these valves, 10 to 15 degree increments. If you never cut more than 15 degrees and you keep your chamber about 10 degrees less than the valve, everything will work out for you. You can turn air 15 degree increments, and the air itself will treat it basically as a radius. It will not detach from the seat. If you cut it more than 15, you have to take liberties with the widths, and the tuning of that whole system becomes really, really critical, finite, touchy. This, you can put these valve angles in any cylinder head and it will work. It'll function just perfectly. So usually we'll have, and we'll get into this a little more, but 12 degree back angle. A 12 degree back angle is pretty much standard in the industry. Is it the optimal for everything? No, there's no such thing as optimal for everything. A 10 degree back angle will work better with lower lift cams, 550 and below, because it's opening up the area when it's closer to the seat. And it allows the air to set up for the turn a little better. But it is detrimental. A 10 degree is detrimental over that lift and can cause turbulence or problems upstream. It's harder to manage that. A 12 degree is like the midline. A 13 degree, that can pay benefits on something like an Australian Pro Stock engine that's turning 11,000 and has 1-inch 50 gross lift. You know, those situations are far and few between. We're talking about off-the-shelf heads, off-the-shelf manifolds. You do this, you're going to be able, the engine will do everything right. Let's put it that way. And again, these are baselines. These are rules of thumb. And like the 90% throat rule. You know, I should have never called that a rule. I should have called that a suggestion, because people take what I say a lot of times too literally. Nothing is written in stone. And that's one thing Joel said probably 5 times we were on the phone earlier today. There's nothing written in stone. Because the seat angles and stuff he's using on some of the super stock heads, people wouldn't even believe it. But it functions because he's willing to make and understands the underlying changes in the induction system, intake path, runner, length, taper, airspeed, exhaust system, combustion chamber he needs to make in order to utilize those angles. So again, if you veer off this, you're going to have to change a lot of stuff to capitalize on the power potential that it would give you. Now here we have 15 degrees, a 45 degree seat, 15 degrees, 30. We got 35, 10 degrees less than the seat, 45, 60, 75, 15, 15, 15. There you go. Now you could cut this as an 85, but a lot of production cylinder heads, to make it easy to manufacture, will have a 90 bored throat. It's not something I ever do. That is detrimental, but in a manufacturing environment, it's a necessity, because you have to put out a consistent product, and you can't come in here and have a team of guys blending throats in. No, it has to be cut and out the door. Otherwise, you know, some of these high-end heads, I'll spend 4 hours blending the seats. That's not profitable at all. not in a manufacturing. So off-the-shelf cylinder heads already have this detrimental effect in there. So if you utilize those seat angles, it'll tune up just fine. If you try to go steeper and still turn at 90, there are things you have to do. Yeah, don't go there unless you're willing to R&D it, change the cams, change the bowl, change the shape of the port in order to accomplish that. 50-degree seats. Now, there's more than one way to skin a cat. This is a baseline, okay? 50 and 35. Now, I usually use a 32.5 here and cut it 50, 65, 75, 82 and blend it in the combustion chamber because my back walls are steeper on some of these high-speed engines. But with a 90-degree throat, production cylinder heads, these are the angles that tune up the best. And I want to accent that word. It tunes up the best. At low lifts, mid lifts, high lifts, it's the best overall average airflow under the curve that you're going to get with a production cylinder head. And then a 55. Again, you're having to cut it at 10, 15 degrees and try not to exceed 15 degrees, although on these last, from the back angle to this, you're always cutting it harder. But from that point on, you try to go 10 to 15 degrees. So on a 55, now you're having to cut more angles to get to 12. So now you have 3 back cuts. So you've got a 55 and a 45, 10 degrees. 32, split the difference between the 12 and the 45 is basically what you're doing there. Also, the widths. The widths of these cuts are hypercritical. If they're too thin, they're not going to tune up at all. It's like not even having them there. If that 45 isn't at least 80 thousandths wide, and that 30 isn't 80 to 90 thousandths wide, it's not going to tune up. If that 50 isn't 45 to 50, and that 35 isn't 80, 90, it's not going to tune up very well. If you only have 50 and 50, it's not going to accomplish the task. The air can't turn that quickly. Width is time. The width of that angle gives the air more time to turn. The wider they are, the more it will accent the throat. If I was running this, I would run 100 and 100. That tunes perfectly. That's the best case scenario on like a 45-degree seat. This would be tuning absolute max. It'd be 80 and 90 to 100. That would be 50, 65, 80, 85. And here you can see we're cutting less angle. The steeper the seat gets, we get to cut them incrementally less angle. So 10, 10, 10, and less. And a 90, 55-degree seats are usually not used with a 90-degree throat. You would have a maximum of 82 right here on a properly designed port, in my opinion. So I would come off a 75 at about 82 and then blend it in the port. But this is kind of the worst case scenario. You're taking a production cylinder head and you want to use a 55-degree seat to tune the flow curve up and higher lift cams. Well, those are the angles that work best. But here's the deal. 45, 60, 75. So that 45 would be 45 thousandths wide. The 60 would be 80 to 90 wide. The 75 would be 100 wide. So you see what happens? It gets wider as the angles get down. Is this the only way to do it? No, this is the way I do it. There's more than one way to skin a cat. So look at the 50 degree. So the 50 would be 40 to 45 thousandths wide. Hold on a second. I keep threatening to get a new camera. So the 50 degree would be 40 thousandths wide is what I run it. The 65 would be 80. The 75 would be 90. 85 would be 90 to 100. Now on the 55, it would be 40, 80, 100, 100, into that 90. Here's the deal. If I took it to 82, I could go 80, 80, 80, 80. But I need that width from a 75 to 85. I need to cut that 100 thousandths wide to give it time to set up the turn. Width is time. You're moving the throat deeper into the port. That's what you have to do when you go from 45, 50 to 55. As the angles get steeper, the angles have to get wider to move the throat deeper into the port to give it more time to set up. I mean, you're setting the ear up real hard here. You can't just set that up and turn it real quick. You've got to widthen. Let me see if I can. So the apex of the throat is like here. Let's see if I can do a pin. Is right here. This one would be way here, and this one would be even deeper. So the throat, apex of that throat gets deeper as the seat gets steeper. Now this is the seat back cut angles that I use on the Australian Pro Stock stuff, or like the JC51. And this is a 58 degree seat. Now you can go 60 degrees on the seat, no problem. But here's the deal. The angle of the seat, the number one criteria you have to think about is longevity. Is this an engine that I'm going to take out every weekend and beat the shit out of and put 400 runs on it before I freshen it? Well, you need to just stick with a 50 degree seat with coated valves. Really. When you come off of a 45 degree seat and you start making them steeper, you need to go to coated valves because the wear increases greatly. With a 58 degree seat, the wear increases dramatically. You don't run this without a coated valve. You just don't do it. It won't last 10 runs and it'll wipe the seat out. So you have to have the valve chromium nitrated. So look at these. These are some crazy angles that we've come up with. Now, how did we come up with these? The same way everybody else has come up with these. We work on the flow bench and the dyno back and forth and back and forth and back and forth to find out what tunes up the best. That's how we do it. No one's going to tell you exactly what seat angles to use in any given situation unless they're extremely familiar with the engine combination and know it like the back of their hand. So 58 degree seat, 45 wide, and then a 47, 60, a 32.5, 80. Those are the back cuts and the widths. Now, why do I not use an 80 and an 80? It would tune up better. It would flow better. It would do everything better. Valve weight. That's the real niche here, is because you're going to steeper seats to tune these high Mach ports and at higher engine speeds when you're up against the valve, meaning this valve is the restriction. And even at some point, let's say the engine, you're trying to run the engine in an RPM range where you're 50 CFM undervalved, or like a Pro Mod that's 150 CFM undervalved. They're running them at an engine speed far and above what the valve can supply. So you're tuning this, you want the biggest throat you could get. You need more area. You have to get more area. Even at the expense of the discharge coefficient. Even if you knock 5% off of the efficiency, that area when you're that far undervalved, when that engine is really needing more air, all the area it could get, it's more power. And there are super stock heads, and Joel was talking about some super stock heads where he's using angles I wouldn't even think of approaching, but he's made them work. But in order to make them work, he had to change a lot of stuff, because you can't just change the angles and go to the dyno. No, you got to change the port and the approach angle of the port, and sometimes you've got to increase the average airspeed a little bit to make up for the loss of discharge coefficient. There's a lot of pitfalls there, so don't think you can just change the angles and it's going to tune up and magically make more power. That if you try to approach it that way, there's a great chance that you're going to kill power, not make more power. So a 55-degree chamber, now that's a steep chamber, but it falls away. This chamber actually comes out like that. It's a convex chamber, not a concave chamber. Now, if you came off of this and went like that, that would destroy the flow curve, because you've lost all the control of the air. You've got this huge throat. You've moved the apex of the throat down with these widths to give it more time to set up for the turn, and then it opens up into a combustion chamber and it loses control. So the convex chambers have been around forever. Now, the valve angle itself in the chamber, I don't have a valve here, but so let's say this is the valve, and the combustion chamber coming off of it at 14 degrees valve angle, that you can usually achieve a perfectly straight combustion chamber, meaning you'll come off of a 55-degree seat with a 40-degree angle and just carry that straight out. It's almost impossible to get a convex chamber at 14 degrees. By the time you hit 10 degrees, it's very, very easy to achieve that steep chamber at the beginning and then form that convex. And at 9.5, like on the JC51s, that chamber is extremely convex. We're talking about a chamber that comes out and it looks like that by the time it hits the bore wall. I can't count how many of these we've went through designing over the last decade. I've probably at least 100 in the last couple of decades. And each different design is for a different cylinder head. Like the NASCAR, I'll show you one of the NASCAR cutters that I was doing when I was doing the heads for DEI and Childress and Hutter and those guys. And it was actually the Hutter cutter. He's the one Hutter is the guy who turned me on to it. And it actually has a radius incorporated in here. Instead of cutting the seat with angles and then going in and hand blending it, he actually incorporated a radius. I'll show you that in here in a second. This is pretty much a standard 45-degree cutter. Now, Chad Spire sent me his new design, and he's a throat nut just like I am. He'll sit there and dick with it for hours and hours and hours, and go back and forth to the dyno trying to figure out exactly if this tuned flow curve actually equals more power, carries it out on the dyno, yada, yada, yada. He's come up with a 45-degree cutter that is the shit. I'm telling you. I mean, I'm not paid for endorsements or anything, but that cutter works on the broadest range of throats and cylinder heads that I've ever seen. And this is one of those things that you just cut it, set it, and forget it. It really is good. And he has different lead-in and stuff than the cutter you see here. So if you need a standardized cutter that will, across the board, achieve really good results, you need to go call Chad and just buy that cutter. I did. And here's a standard 50-degree cutter that I use and have used for 15 years now. You notice the top cut is a 48, so it's only 2 degrees off. So this is for convex chambers. So you can use that on a concave chamber as well. There's no problem. But this is something that's going to come off of that top angle and just roll out like that. And if you don't want it to roll out, say you have a chamber that comes like that, well, that's fine. Just blend it in. Having that there in a concave chamber, like a 23-degree small block chamber, that helps a bunch. When you try and do this stuff, come off of that into the chamber and just do this and lay that down, and you keep laying it down and laying it down, you lose control of the air. And the flow detachment can cause choking. It decreases the efficiency of that throat because now you've lost control in the combustion chamber. And I see that a lot, but here's the deal. If you put it on a flow bench, the flow bench will tell you you're doing the right thing because the low lift numbers will go up. It'll get louder and more turbulent, you can hear it. But on the running engine, it's not dynamically correct. The flow bench lies to you all the time. Here's my standard 55-degree cutter. This is a cutter I use on so many things, especially if it's already had a valve job. You see this radius right there? It comes from the 55 into a 65 undercut and then goes into a radius into an 80. So if the throat is blended improperly or offset or screwed up somehow, that little radius right there can kind of save your butt. Instead of trying to dig in to a throat that's already too big, and now you're having to take more out and making it bigger yet, you're making it bigger, a throat bigger that doesn't have the proper angles, doesn't have the apex depth proper to give the air enough time to turn, and now you're making it bigger by digging in. You're just making the situation worse. And I will sell these standardized 50 and 55-degree cutters. If you message me, yeah, I can set you up with the cutters. What we're looking at here, even though the flow curve itself isn't the primary indicator of creating more power with steeper seats, this is the effect of what happens. So I'm going to, if I can find my remote here. Oh, it's in my pocket. So what I'm going to do is tune out here and just use this. So right down here in the lower portion, this is 0.600 lift, about 550. This is the convergence point. If you don't know what the Venturi convergence point is, that is where the throat area, so let's say this is the throat, and the valve is lifted up here into the combustion chamber. This is where this area here and this area all the way around the valve, the circumference of the valve is the same. Now, why is that so important? Well, you notice right here, it doesn't change. That point is like a teeter-totter, up and down. You kill the low lift flow down here, and the high lift flow comes up. Right here with a 45-degree seat in the white, because the throat is steeper, it cuts the air harder, so it can turn the air better around the valve when it's close to the seat. It accents the lower portion of the flow curve, but it's also detrimental up top from a flow standpoint. But it doesn't change at the convergence point. You're not going to affect the convergence point almost at all. Why is the convergence point so important? Well, when that throat and the circumference of the valve, the curtain area itself, are of the same area, the airspeed starts to saturate the port upstream. Now the airspeed is not just reacting on the throat close to the seat, like down here, it's also reacting on the short side. And now your short side comes into play. So if your short side's screwed up, laid back too far, too tall, what have you, it's going to affect this. So let's just look real quick at the 45 degree, which is the white dotted line right there. Let's say after the Venturi convergence point right there, let's say the short side was messed up. It's too steep. What would happen is it would do this. It would nose over. It would get loud. You can hear it. This is the point right there. After that point, if the port gets loud and you have flow detachment off the short side, you'll hear it. The port has to be dead silent all the way from that point on up. That is an indicator that you have hit the nail on the head. You're doing good. If it gets loud and nasty, that is an indicator that something is amiss. It should transition through that point silently. That's harder to pull off than you can imagine. But okay, the 45 degree seat. You see it turns the air harder, let's say, more abruptly when the valve is close to the seat. But because those angles turn the air hard, it's detrimental up here. Now you notice at 900 or 0.4 LD, this is LD ratio right here. This is valve diameter divided, or that is valve diameter times 0.4 is what that is. 40% of the valve diameter. That's actually the correct way to look at this. Using just lift numbers, it's hard to compare. I'll get this pretty soon. With LD ratio, using these numbers, you can compare valves more easily. If you look at if you're just looking at 600 number and you have a 2800 diameter valve and a 2-inch valve, they're going to occur. This convergence point is going to occur up here on a 2800 and down here on a 2-inch valve. But it will always be at 0.25 or right at about 0.25 LD ratio on no matter what valve size you're using. So on the 45, you can see it turns the air better down low, but up high, it's nosing over. So you go to a steeper seat, a 50-degree seat. That's the green line. That's this one right here. Right here. The green line. You can see down here, it doesn't, because you're using steeper angles, you make them wider to give the air more time to turn and set up for the valve, turn around the valve. But you'll usually see a little bit less flow down here before the convergence point. But after the convergence point, it will definitely pick up sometimes, 20 CFM up here. So higher lift cams, you're moving the whole flow curve, the area under the curve. If you looked at it, for a 900 lift, the area underneath that curve is a lot more airflow for that. That's a lot to erase. Also, another thing you see is the you see this right here. The flow curve goes up. It actually increases per unit of lift after about 0.4 LD ratio. Now, why is that? That's because the valve is basically out of the picture. It's all port at this point. And now you go to a 55-degree seat. Now you can see that after 0.4 LD ratio, you see this spiking, and it's amazing. Sometimes on a 58 or a 60, you'll see it like shoot way up, like 121. I've seen 125 CFM per square inch of valve area, 141 CFM per square inch of valve area at the throat up here. But that's an area you're not going to lift the valve 0.45 LD unless you're extreme pro stock. And this up here is not going to do you, any good if you only have an 850 lift cam. Right. But the area under the curve is still better. You can still utilize it, capitalize on that with an 850 lift cam. I'm not saying that you should only use steeper seats with high lift cams. It doesn't work like that. But it's more about how much more area do I need? Do I need to push this throat as big as I can? If you have an engine that doesn't require more area, you have plenty of valve to feed that engine in the power band that you're running it, and you use steeper seats, will it make more power? A lot of times, no, it won't. It's when you're trying to push things, the engine speed and everything else up, that you start really seeing the benefits of this. And the wearability too, you've got to take that into account. So this is like a big block Chevy or a 23-degree small block Chevy port. They come in really steep. Let me change that color. They come in really steep on the back wall right here. So if you were to, let's say this is a 45-degree seat right now. let's say it's 45 degrees right now. And the bottom angle is an 85 degrees right here at the throat. And you go to a steeper seat, so we're just going to go to a 55-degree seat on this thing. Well, now, with this steep wall, you're trying to turn the air a lot harder, and it gets almost impossible to move the apex of that throat down by making the seat widths wider. So what do? You have to fill the back wall. What I would do there is I would fill this back wall right here, if I could get it to right. Fill that back wall in like that, lay the short side back, and carry this in. So my angles, so I'm coming off the C, and instead of having to go 90, I would fill that back wall like that, so I could continue this angle. So again, if you're going to go to steeper seats, you have to change everything around it in order to really make it function properly. And this is why you see Heimbach Pro Stock ports. This is why they're laid back like this. So using a 58 or even a 60-degree seat is really simple when your back wall is, you know, what, 85 or so. And off-the-shelf Manley valve. I've showed this tons of times before. If you look, let's see if I can. You can take a standard valve, just so long as this width right here is wide enough. Man, you put a 30-degree back angle on that, and if you can achieve at least 65 and a 70 thousandths width right there, that's 10 to 15 horsepower every time we did it. That's how much seat tuning that throat up can help. Now you're going from a really crappy situation that doesn't flow well, and you're going to gain 15 CFM at 500 lift, and overall flow curve will probably go up 20 CFM just by doing that, because you're tuning that venturi. The venturi is more efficient. It can set up for the turn around the bow and the throat. A simple back cut like that. Now, if I went 80 and 80, or better yet, 100 and 100, wow, that would be another 5 to 8 CFM and even more power. And this is a Hemi Super Stocker. This is one of those situations that's outside the norm. This is, there's no book you can turn to say, oh, what do I do with a 20-degree back angle? Why do I use that? Because a super stock head is mandated to the stock intake port CCs. And if I didn't mill the flange off to make the port shorter so I could increase the cross-sectional area and run a tulip valve to take up that CCs in the port itself, so then again I can increase the cross-sectional area even bigger, you could get this thing past 9 grand. It would kill 50 horse, just about, if you try to utilize a stock head at the stock CCs. Yeah. But we mill 750 thousandths off the intake flange. We sink the intake valve 70 thousandths. And then we put this tulip on there. And by doing that, I could just, and I mean just, get the cross-sectional area the same as the throat. I can't even get it bigger than the throat. That's how hard it is to get area in these things. This thing could turn 11,000 RPM if I could get the port volume in it, but you can't. It's holding it back. So all I could do is just try to make the whole thing not any smaller than the throat. So the airspeed, the mean gas velocity in these things is stupid fast. So what do you do with the throat? Well, you use steep angles, and I'll go 58 degrees on some of them. But now we can run titanium valves in them. Thank God NHRA did that, because the valve you see here is 110 grams. A stock valve you see over there is 150. You aren't turning a 150 gram valve 10 grand. These things go 10,000. They will make peak power. This one made peak power at 9 with 1,050 and carried that to 10, and it dropped about 20 horsepower. So it carried the power awesome. A lot better than I thought it would. But this valve, this is a steel valve. It's hollow stem. It's not only hollow stem, it's only 150 thick right here at the base of the radius, and it's only 160 thousandths thick right here. So the valve itself is an eggshell.
Right.
We pushed it. So you run the biggest throat you possibly can. You're dying for more area. Just 10 more thousandths bigger in the throat can net me 5-10 horsepower on this thing. That's how touchy it is. So you put you turn the air with a valve. The throat's huge. It's 94, 95%. And you put these back angles on here. This is what's turning the air. The valve seat does almost very little, but it's very steep. If I can draw it, I mean, the port comes in basically like this. This back wall is super steep. I mean, it's just straight. So when it comes off that seat, I think the bottom angle is 70. So it's a high Mach port. It's shaped like a 4-valve head would, individual port. It's just straight in over the valve. And you're talking about a 2250 intake valve moving 485 CFM at 1-inch lift with this thing. And if I could make them wider, I would. I definitely would, but I can't afford the weight. But with the tie valves, that's opened up a whole new world. Now we can play a little bit. We've got some room to play. I don't know how, okay. There's more than one way to skin a cat, and you can develop seat angles underneath here to where you don't have to blend the port. It's not a controversy, it's just there's two different ways you could do it. You could do it with straight angles. It's easier to do it that way. It's less touchy to do it that way. It's more consistent to do it that way. But I went to the Lee Shepard School of Head Porting. This is the way he did it. This is the way everybody he trained did it. And those guys trained me to do it. So this is the way I'm the most comfortable. Now, I could squeeze a little more out of this, but like I said, this is a Hemi Pro Stock head. This is a Mopar. Blending seats like that, you're playing with 5-6 thousandths. You can't. So you're looking at 4 to 6 hours just sitting here blending these things, just pushing them out, getting them absolutely dead on perfect. So it's more labor intensive, it's harder to maintain consistency, and it's a genuine pain in the ass. This is a Pro Stock valve 2.5, this is a 2.550, no, it's a 2.575. 2.575 intake, and you see the width of the back cuts on this thing. Now you're looking in a modern Pro Stock head like the JC51s, you're looking at a 93 to 93.5% throat, and the apex of the throat is a good 375 below the seat. So it's very steep, and it sets up for the angle really deep. So the throat itself is not turning the air, so you have to do this. Here we go with the valve weight again. This is 2,000. You can't afford this, even at 10.5 really. You have to narrow that angle and get the head thickness down and get it down to minimum weight the best you can, 92 grams. So when you're pushing the engine speeds higher and higher, you need these back cuts here, but you can't afford the weight. So you're sitting here playing constantly, fudging back and forth. Can I change the back angle a little bit and come off of it differently? And again, those baselines I gave you will work across the board, but when you get into this stuff, now you're just kind of playing with fire. This, this is a Extreme Pro Stock valve out of a Hemi from 2010, I think. And this is 96% throats. The biggest throat I put in anything, because those things are screaming for more area. Any amount of area you can give them, they just respond. Just as long as you can maintain the flow. And even at the expense of the discharge coefficient, if you can gain a little bit more airflow and area, it'll respond. But you're turning the air with a valve here because the throat's just huge. And this depicts a properly set up venturi to turn the air right close to the seat, like a 45 or a 50. So let's say you blow the throat out. What happens? Flow detach, flow area decreases because you can't set the air up for the turn. Well, what could you do here? Bring the chamber up. Bring the chamber up. Anywhere that's dead, I would bring that chamber up to try to recover that air. The divergent region, the combustion chamber, has a lot of control, especially close to the seat. And this little anti-reversion cut right there, that was used a lot in NASCAR, road racing, and stuff like that. Some of the F1 valves, they literally come off straight like this and actually go like this as weight savings, and they distort differently, and it's a little bit of this right here is a little bit of anti-reversion. That's a 15-degree cut right there. And I leave that right there, sharp, 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 like you could shave with it. The worst thing you could possibly do is radius the margin of an intake valve. Your EGR, your exhaust gas recirculation, your overlap, it will revert worse. I've had a lot of talks with a lot of pros, and this across the board, sharp as a razor. And this is 15 degree is just a way to try to set the air up, to try to shoot off of there and not come around the valve. You don't want, because when the valve is close to the seat, at low lifts, the piston isn't doing anything. There's no depression. You're just relying on the dynamics of the intake and exhaust to move air through the engine. So any little pressure differential could react on the intake port quite quickly. So anything you can do there to keep that from happening can pay pretty big dividends. And if you're already on the edge and you radius it, it'll EGR. Split picture of both scenarios. Now, in this scenario, you can not only bring the chamber back, but you could add another back cut there. You can make them wider to try to set the air up better. You could try and use the valve. It's much less effective to try and use the valve to do that. And now you're making your head thicker, the weight skyrockets up, and you could add 10, 15 grams to a valve real quick with a back cut. Now we're going to get into offset throats. which is something you only see in extreme circumstances. Now the throat itself, the blue right there is the valve, and the throat itself is moved over here. So you will see 4 angles over here, and you'll see the seat and maybe a sliver of a 60-degree cut over here. I know that might be a little hard to visualize, but over here you'll see the seat, the 60, the 75, the 80, and the 87, and on that side you'll see the seat and the 60 and the throat. Now why do we do that? The valve is really close to the bore wall over here. There's no airflow over here. There's no air speed over there. And the last thing you want to do when the valve is close to the seat against the bore wall is turn the air into the bore wall. So if this is your bore wall right here and your valve head is right there, you don't want a throat coming in here to turn the air into the bore wall. You gain sometimes a significant amount of airflow and air speed. You're making this area more reactive because this is where the engine detonates and leans out. What you want to do is have your little seat right there carrying into the bore wall, and the throat just comes almost straight down. So now it can shoot right past. You're going to increase the airspeed, make it more reactive. The reversion is going to act less on that area, and when you get the airspeed up over here, you can move fuel over there. This is the lean area, and this is the area that detonates out of the piston because it's so damn lean. You can't get any fuel over there. So when you make it more reactive, you can move some more fuel there. And this is an actual offset throat. And this port is coming in, it's coming in about like this. So on the short side area right here, you've got a seat, a 60, and a quick radius. And over here, you've got 6 angles on the back wall. In other words, what it would look like is, let's see, there's the chamber. Let's go back. So you would have the chamber on the back wall, and it would be steep, and the short side would come in, and it would be like nothing. But you can see all the angles on the back. That's a horrible depiction, but hopefully you get what I'm saying.
Mm-hmm.
This is the actual velocity profile of the seat, low lift. So you can see all the airspeed is back here, and right here is the slowest area. So if you offset the throat, this red right here would carry on. You would increase it quite a bit. Now this is a blended offset throat. See if I can. No. Right here you've got, you can see this, the top cut. Here's the seat. You can see the 65, 75, 85 blended in. Now over here, you see the seat, 65, and no angles at all. Again, over here it carries off. So what you're doing is, this is something you have to hand blend, and it's a pain in the ass and time consuming and really hard to get right. You don't have to blend everything. These are this is a port set up for defined angles, meaning there's very little blending involved at all. The throat's not offset. If it is, it's slight. Does that come through? But yeah, it's kind of.
Mm-hmm.
But what I want to show you here is the angles themselves, not the width, not the angle itself, but how sharp it is. Sharp edges. Sharp edges are extremely advantageous for wet flow, to vaporize the fuel. On the wet flow bench, those edges light up. It just, the fuel, the air will conform. The fuel will hit that sharp edge and fan. It will re-atomize the air-fuel mixture. That's why a radius seat on any intake is a total disaster. I mean, the air-fuel ratio is much less homogeneous with a radius seat than sharp angles. And when I do a valve job, I will go in and sharpen those angles up, not just in the seat, but the valve itself. I'll hit every single angle and make sure they're sharp. Razor sharp. The sharper the angles are, you will see, it's a power difference. You'll see it. I mean, we're talking 2 to 4 horsepower. It's not a lot, but if you see 2 to 4 horsepower, it's obviously the correct direction to go. All the sharp angles. On an NA engine, you want the chamber to be dead sharp across there. Now, when you have power adders, such as nitrous, that's not what you want. You radius everything off. But for NA applications, sharp, sharp, sharp. Every single edge right there is a vaporization ridge. On the wet flow bench, the ultraviolet, it's amazing what you see. And any vortex generation and fuel separation within the combustion chamber, when you see the vortexes generating, if you radius that seat off, that vortex will just grow. The fuel just falls out of suspension and it just forms a ball and just burns too latent to be useful to create any usable cylinder pressure. And here, oh, let's go with racer. Nope. Nope. You can see on here, let's go to our pen. You can see the residual fuel right there. Let me go to, yeah, maybe that's a little better picture.
Yeah.
Okay, let me see if that lightens it up a bit. Yeah, that made it a little brighter. You can see that residual where the dicum separated on that ridge right there. This is a 4-valve. This is a IRL, Chevy IRL engine. And you can see that the fuel separating off of those off of the back cuts around the valve. This engine had a problem because you can see how much richer it is. The blue is at mid-lift and the red is at higher lifts. And the injector placement on these was upstream prior to the divider. These are individual ports. So each valve has its own port. So the fuel was splitting and making one side of the combustion chamber richer, and it wasn't doing a good job of homogeneous air fuel mixture in the combustion chamber. Here's a good depiction of a wet flow. This shows the difference in a port with a wing designed for a wing. And again, you can't just stick a wing in a port in the floor. It has to be designed around the fact that that wing is there in order for it to function. But this is prior to widening the short side and doing whatever we do it in order to put that wing in there. And you can see the air-fuel separation, especially at the plug, a huge vortex. But you can see the fuel busting off. Look at that right there. look at it separating off of that ridge, off of the cut itself, with like the 65-degree undercut. And then you put the wing in there and widen that out. And now you can see it's split into two tiny trails. And again, you can see it vaporizing off of the undercut. This is what the fuel does, by the way. If the short side pressure is low enough, meaning you've got it into the proper airspeed range of about 350 to 380, this pressure differential right here will pull the fuel and it will turn. That's what pulls the fuel off the roof. That's what turns the fuel. It's pressure differential at the short side apex. And you can see how abruptly, I mean, I've seen this, you spike the airspeed at the short turn, that fuel will come in and just go, and turn almost 90 degrees. It will yank the fuel off of the roof. Here again, you can see the guide, the roof. The fuel comes in because my pressure at the short side is correct. Okay. It literally came in, went back, and then conformed to the short side. That's how hard it yanked the fuel down off the roof. And if you ever want to know where you put the wing behind the guide, this is how you know. This wing is in the wrong spot. It should be right here, because that's what the pressure dump behind the guide is telling me to put it. And it should be shaped broader over here. That's the way the wing should be shaped, not over here. So I had it in the wrong spot. All you got to do is Dykem trail it. It will tell you where to put the wing, how wide to make everything. And if it's in the right spot, it will be red all the way around there. That's it.
Wow. I'm telling you. You know, it hits home right there. Send the heads back to the guy that did the valve job and the port work.
Yes.
I mean, I don't know how, I guess I've never seen the angles like this in this explanation. It just blows me away how close they are degree-wise and how big of a change it makes things. You know?
You take a finely tuned intake port and change one angle.
Yeah.
I've seen people go in there and blow the throat out and just not pay attention to what they're doing. 20, 30, 40 horsepower gone out the window on a high-end cylinder head like that.
And with that Hemi head, it just shows you that the 90% rule, so to speak, or suggestion is a suggestion. You know, that Hemi wants as big as you can make it in there.
Yeah, you literally can't make it big enough.
Yeah, it's crazy. So we got 124 people here. I know there's going to be some questions on here. It is. That's pretty good. A couple guys said something about the commercials. I can't comment on the commercials. You know, I can't. That's YouTube. They're the ones that put those in. So they, I can't say much. On the membership though, we don't have any of those. We turn that stuff off. You know, and we try not to have any commercials. I don't know if there are.
Yeah, we're at their mercy. We can't do anything about it on these live sessions, but
right
on the members, I hate them too. That's why on the membership deal, I'm like,
no. The other thing about notifications, people are saying, hey, I'm not getting notified. No one told me there was a live chat or a members live chat. Now, I had put a post on there because I was in a membership group for YouTube on a private aspect. And they were saying that they were having problems, or they have an algorithm where they only give people that subscribe so many notifications. They don't want to over notify. So if you have a bunch of channels that you're a membership of and you get notifications from those videos, then you might not get one from ours. So we're trying to
Can we generate a private email list, maybe?
it's possible,
Yeah.
because the reason I'm cautious about emails is because I got busted. Our channel got hacked because of email. So I'm cautious about that. That's why I took it off the YouTube page, the description or about section, because, get all these people who I don't know who they are. So you got to be cautious with that aspect, because people were asking on here, and I'll go down and ask them or read what they had to say. They said, I'll take a cutter. How do we arrange this? Now that is through Chad Spire, the one cutter that he had. I saw he had them for sale. They just came in and he sent them all out. So that's something that we can talk to Chad about if he wants to. I'll put a regular post, this email or however. Go ahead, Darin.
If you want mine, it's
and I think this is what Mike is saying also. Also, what is the other contact info to buy the other cutter you recommend? So there's yours and then there's Chad's.
Yeah. Hold on a second.
And you're right, Tim. Necessity is a mother invention. When I saw that dampener, so to speak, on that cutter, I was like, what the hell? Never seen nothing like that. And you think about that thing spinning, it's like the fluid dampener. And he was saying, oh, yeah, you should have fluid dampener, make one for a cutter. And I don't know if you guys use something like that. Put it in the comments, because I like to read the comments and stuff and answer what I can, or will refer and try to get back to them. But I don't know if anybody else does that themselves. Let me make you. Now, I'll tell you this. Darin gets a lot of emails, so he does what he can to answer them, but there you go. All right?
If you want a 50-degree cutter or a 55 or a 58, the standard cutter, just email me there. I'll set you up.
Perfect. Now, when I see those cutters, so they have the angles already cut into them. One cutter has more than one angle. Am I right?
Yeah, it has all the angles.
Okay. Man, that's crazy. Which comes to another question. Sam Vincent, I don't know if you know Sam Vincent, but he was asking a question about, and I don't know if you're still here, Sam, but he said, what about the margin thickness? How do you determine that, or how do you keep it to a certain parameter if you have all these angles?
Optimum margin thickness is right at 45 thousandths to 50 thousandths. Anything over 50, it can be detrimental a little bit. Okay. But usually we'll start off with a 50 or 55 thickness. In an endurance type application, something's got to go 1,000 runs because it needs to be freshened up. And as you grind the valves, that thickness is going to go down. But on a comp motor or a pro stock deal, it's 45 thousandths. That's
okay.
And once it gets under 35, it becomes detrimental again. You get flow separation and it gets a little loud. And it deforms too.
The valve itself?
Yeah.
Yeah, okay. All right, there you go, Sam. Thanks. Now, Turner's asking a question. He says, hey, guys, Darin, how much spark plug thread should protrude into my small block Chevy Badass Wilkes Performance cylinder heads?
Well, it depends on how bad the plug position is.
Okay.
If you have a recessed plug that's down in a hole on one side, let's say especially with 23-degree chamber, the chamber comes in like this. If you have a spark plug that's flush, you don't see a 23-degree head with a flush plug. I don't think they exist. usually the plugs will come in like this. So now the plug is right there, and now you've got air-fuel separation and puddling in this hole.
Mm-hmm.
So if you stick it in a thread, it can help. Just radius off the margin of the plug around there just a little bit. And on some of the older Pro Stock stuff, I used to stick it in 4 threads and radius off the plug and polish it, but those only last 1 run. So, and that changes the heat range, and there's a lot of other problems associated with playing around with that. But it depends. It depends on how bad a plug position you have,
Okay.
and how often you're willing to change plugs.
Okay.
And if you protrude it in there, you're going to have to go down in heat range.
But you at least want the edge of the spark plug to the edge of the combustion chamber.
The perfect case scenario is flush with the chamber.
Okay.
Absolutely perfectly flush. That's not always. If you notice, that's a flush plug, a Pro Stock head.
Sure.
Or the best plug position. Where is that Hemi? Did I go past it again? Yeah, it did. See, even on the Hemi, it's got a little recess right there.
Yeah.
But with an extended plug, it's not that bad. It doesn't have too much fuel separation there. But see, I would stick that in another thread at least. Maybe a thread and a half.
Okay. Now here's a
Now,
question.
you would never want to do that with an endurance application, a road race application, or something like that.
eCrusher74 says, the Coanda effect is a physical tendency of a fluid, liquid, or gas to stick to a nearby curved surface and follow its contour, rather than moving in a straight line.
Yeah.
There you go.
I think we've covered the Coanda effect many
Yep.
times on the channel.
So thank you.
The actual atmospheric pressure is if the air is a sharp corner, the atmospheric pressure is literally high velocity, low pressure is pushing it around the corner.
Thank you, Crusher. Don Dotter says, Darin, can you tell us the Dykem method?
The Dykem method on the flow bench is I will take spray Dykem about 2.5 feet back and about 2.5 feet high and just spray it for 3 seconds and let the port take it. Don't spray it in it. The port has to take the mist as it falls down over the radius, and then it will follow the natural. And you can sit there and just spray and spray and spray if you want. It doesn't hurt the bench at all. The Dykem dries before it even hits the orifice plate.
Okay. Thanks, Don. Mariano says, good information like always. Thank you. Is there any way to sharpen the cutters? How do you get sharp angles? Do you touch it with stones?
There are many different ways. Many of the machines have sharpeners built into them, or you can buy a tool sharpener with a diamond plate. You can buy diamonds plates off of eBay or wherever and get like you need one with about a 600 and one that's about a 400. And I have a 4.6 and 1,000. And it needs to be really smooth. Otherwise, you're going to get lines in the seat. So I'll go 4.6 and 1,000, or just a 6 and 1,000 to touch it up.
Another guy says, not sure, 723. He says, use Bravo browser to get rid of ads.
Brave browser is awesome. It won't share your information. It's the most private browser out there. You can also go to the Google Play Store. There's YouTube ad blockers all over the place. I shouldn't say that, should I?
I don't know. I don't think it matters. I mean, I'll tell you the truth. I ended up, once we got hacked, I got malware bites with a VPN and everything else.
Yeah.
I get no ads on any YouTube.
And Brave has a built-in VPN.
Does it really?
Good.
Really?
Yeah, because all my traffic goes through the Netherlands, Denmark, Japan. There are countries that have a lot more open internet, and YouTube won't hassle you.
Bingo. There you go. Thank
Because you got to sign in, and then they share your information. Yeah.
Now Tim says from Optimum Inform, he says I got a bunch of notifications this time, so I don't know, man. It's one of those hit or miss, you know.
I tried to share this one across platforms and
Same here.
different organizations, so maybe that helped.
Eric says, Darin, if hammerheads and airstrikes would fit the same block, how would they stack up against each other? Now the hammerhead, you know what that is, right?
Yeah, the hammerhead Hemi.
Yep.
That's a good question. That'd be pretty close, I would think. Yeah, it's hard to say, but I think they'd be pretty close.
There you go, Eric. Pretty close. Take it from there. Now, this is interesting. Not sure 723 says, I found a Tim Halstead fake profile on Facebook. So
send that to us. I'd like to see that.
Yeah, I would too. Here's what I'll tell you that Facebook told me. They said once you get to a certain amount of followers, which I'm at almost 29,000 followers, that's when you start to become a high profile. And Darin switched his profile around now to a professional mode. So they have a thing called protection. So another one of these sign-in protections. I'd recommend getting that kind of stuff because the defense you need against all these hackers trying to get your personal information or take over your Facebook account or whatever. Think about that, guys. It's a word from the wise. But yeah, send it to us. I'd like to see it. Message me with it. Nutbus says, NA engine, is it okay to have sharp edges in the chamber or can it make pre-ignition problems?
It can. Well, let's say it would make, especially the dividers between the two valves. If you notice right here, those should never be dead sharp, especially right there.
Mm-hmm.
That can get to a point if you're lean out, you're a little bit too lean, too much timing, it can initiate a pre-ignition scenario and cause detonation. So you notice those are radiused off. Those are not sharp. And also this is laid back right here. This will mess up an exhaust port faster than anything. This is laid back right here. The air comes right here. So the air is trying to come across this into the exhaust port.
Mm.
And if you build this up and don't lay that back right there, that causes turbulence and a whole bunch of other problems in the exhaust.
Now, Jeff, he's a member of Knowledge's Power, and he says, I have run that intake valve top cut for anti-reversion, and it literally changed the running characteristics. Smoother
Especially
everywhere.
off idle and transition, the transients, hell yeah, it will.
Thanks for some real life experience, Jeff. We appreciate that. Kid IR says, Darin, the man, thank you. Regards from Iceland. Do these cutters fit into the 3D fast cut holders?
3D fast cut. Is that the ones from Goodson? If they are,
Goodson?
yeah. It will. It's a Surrey style cutter, the old Surrey style cutter.
What'd you say, Goodson? Is that who you said?
Yeah, I think
Okay.
the 3D fast cut system is from Goodson, I think.
So guys, make sure that you push the like button on here, and that keeps us going in the algorithm and keeps our videos in the forefront. Extreme Performance Engines 1901 says, can you define a top angle cut off the seat? Is it a good idea on a 23-degree small Chevy Edelbrock head to radius off the flat of the chamber to the chamber wall?
The flat. I don't know exactly what you mean by that,
Yeah.
but I'll show you. Where the hell is my... Oh, I discarded it. Let's make a new one here. So by the flat, I'm assuming dang it. So your valve head is here, and the chamber wall is right here, and you're saying the flat right there. That's probably what you mean by the flat. Should it have a radius there? Yes. And as a matter of fact, it's hard to get this, but you can carry that like that. Doing this and doing that, it's close to the same thing, but yeah, it should have a radius there. At the very least, it should have a small radius, if that's what you're meaning there.
There you go, Extreme Performance. Put it down in the comments if that's what you're talking about. You know, that brings a good example of a canted valve head, why that's beneficial compared to offset throat and this type of situation. It reduces that, right?
Yeah, it moves away from the wall.
Okay. And hey, I really appreciate this, Blitz Cylinder Heads. Thank you for donating. He says, thanks, Darin. There are a lot of talented cylinder head guys out there, but not many willing to spend the time sharing their knowledge. Even fewer have the ability to teach effectively. Thanks again. And you're right, man. When you listen to these lectures after the fact, like go back, a lot of guys tell me they listen to them in their garage or something. And I even do the same thing. And it's like, wow, look what I picked up on this. I can't believe I missed this during the lecture. Or just the way you explain things, it's like, wow, I can get like that valve job. Having you do the valve job who did it in the first place, you know, hits home. Thank you. So Nigel Paul says, I have a set of the 99 Mopar heads at work that I'm repairing at the moment. I've looked at the ports and they are wild, just as Darin described. Thank you. We appreciate that, sharing that with us. Slug says, I've had some customers request their decks be not perpendicular to the cylinder bores on some applications. Can you shed any light on what they're trying to achieve? Appreciate everything you guys do.
You lost me there.
Decks.
Yeah, I don't know how it... You mean the deck of the block?
Yeah. Well, I took it as
Oh.
the head, but
Cylinder. Perpendicular to the cylinder bores. The decks. Yeah, that's to prevent one side of the piston hitting the chamber harder on overlap. If that's what you're getting at. So on overlap in the direction of rotation, your piston's going to cock and hit. So if your deck is flat and this piston, excuse my shitty artistry here, on overlap is going to cock. It's going to cock as it comes around. So this is going to hit and this is going to move away. So what we just do is cut the piston 0 to 12 to prevent that. So it touches perfect flat on overlap, on lockup. That's what we've always done. We just cut the piston, if that's what you're referring
to. So David Johnson says, Brian Salter changes the margin angle, comma, in a hole. Have you ever experimented with different margin angles?
Oh, yeah. Yeah, absolutely. Especially early in the NASCAR Ford SC1 Yates heads, that series of cylinder heads,
Yeah.
They have no cant. They've just rotated the valves, but they're still 0 degrees, no cant. So, you know, you would have a margin, let's say, that's horrible. That's worse. So let's say your valve head, you have straight margins. What you can do, especially on non-cannon valve stuff, there's lots of ways to play with this. What they used to do is have the margin come off at like a 4 or 5 degree angle, and then they would cut a 60 right there. So let's blow it up. So I can't draw a straight line to save my butt. Let's see here. So the margin itself comes off at a little angle, and then they'll have like a 60 leading into the 45. So the 45 is actually right here, and the valve is larger than the seat, and they're turning it with the valve head. If that makes sense. Draw up a big. So instead of having a straight margin like this, they will bring it in at like 2 to 5 degrees, and then they'll have just a little bit of a 60 right there before the 45. So the valve is a lot larger, but they're controlling the pressure recovery with the valve a little bit.
Okay.
And that helped those heads a great deal, actually. Yates was the first one I saw doing that. So you'd have a 45 degree seat, but you'd have just a sliver of a 60, and the valve was bigger. More than one way to skin this cat. Those heads had a real bad flow separation, and they would go backwards at about 750 lift. It wasn't detrimental to them at the time. That was their gross lift.
Okay. Pontiac 411 says, when porting a head, should you start by measuring from the valve guide to the bowl wall to center each bowl to the valve? Most seem to just start porting without considering course shift.
You lost me there, man.
come back to it, add something to it, maybe Pontiac?
Yeah.
Okay. Michael says, when you use the seat cutters that cut all the angles at once, does heat come into consideration during the process? Do you stop and let the seat and cutter tool cool before you make a final cut?
No, the heat buildup's not a problem. You're not removing that much material. And most of the heat goes into the chip anyway. Yeah, that's not a factor.
Okay.
But everything moves. If you have a guide in a head, and maybe this might be what the other guy in the previous question was trying to elaborate on.
Yeah.
Let's say you have a guide and you cut a seat, and then you go and port the whole thing, that guide's going to move. 1/2000th at least.
Okay.
If you port the chamber and everything else, the seat, and then you cut the exhaust and port it all out, the seats are going to move 1 or 2. Pretty soon, it's 3/1000ths off, which is why we do 3 valve jobs. We'll do a rough valve job, like 8 high. I'll get most of the port work done, what have you, if I'm hand porting it, or the CNC. And then we go in and take it 5/1000ths down, do final blending and everything. And then the last, we'll do that final 5, because the press fit, the stress, in the combustion chamber from the press fit of those 2 seat rings, I cut the exhaust first, then the intake, do the porting, cut them again, and you'll see they'll move, especially between the seats.
Mm-hmm.
Oh man, it'll shadow there. When you start relieving the stress by porting, taking that material out, everything's going to move. Pretty soon, that thing will be 4 or 5/1000ths out.
Wow.
The more material you take, the worse it's going to get. So you just keep doing valve jobs until you arrive at the final situation.
But cylinder head says, I noticed some new LS cylinder heads are designed with canted valves, but still use a relatively low lift of around 700. Will the canted valves really provide much of a performance improvement?
Oh, yes, they will. A lot of power. 40 plus.
Really?
Yep.
With that limited lift to 700?
Yep.
Wow. Okay. Dang it. Well, there you go, Blitz. We appreciate you being here. Thank you.
Those new BTR canted valve LS heads,
Yeah.
it's shocking how much more power they make.
There you go, boys. Chris says, hey, how wide do you make the seat on the exhaust valve? Does the geometry hold for smaller valves?
I need to know specifically the geometry that you're referring to, but how wide do I make the seat on the exhaust valve? It depends on the situation, but for endurance application, 50,000ths wide, it's going to get wider as it runs.
Yep.
And on like a pro stock Australian deal, a competition eliminator engine, it'll be about 10,000ths smaller than the valve, 30,000ths.
Okay.
Wide. And on the valve itself, 55,000ths wide on the valve itself.
So hope that answers your question, Chris. Clark says, hey, what's the advantage of a 50-degree seat versus a 55-degree seat?
Well, it depends on the application,
Yep.
but if you're up against the valve and you need more area and you need to raise the engine speed and you absolutely have to shove things right to the edge, 10, 15 horsepower on a high-speed engine.
Perfect.
58 will add another 4 or 5.
Michael says, I got quite a few notifications from YouTube, and I shared on Facebook a bunch. So thanks, guys, for letting us know. And, hey, feel free to share any of our stuff as far as live chats coming up with any of your buddies or put it on your own post on Facebook. I did this one at least 3 or 4 times to keep things up there because it gets left behind. Darren, does Chad sink his intake valves on super stock small block Chevy heads to maintain port volumes?
Yeah, you always have to a certain amount. I mean, usually it's 40, 50. And you're dealing with a really crappy chamber. I mean, it's
Right.
flat. You got to, you're trying to get some top cut. You're trying to get some control, you know, over the exit. Some pressure, some semblance of decent pressure recovery. So it helps in that regard. It it decreases the short side height though, so that plays into hands. So you have to kind of split the difference. How much short side can I shrink when I need more short side to turn the air, or lay everything back and take the short side down and sink the valve to get the area? And the latter of those two is usually the plan.
We'll have Chad back on, and then you can answer that, ask him
Yeah.
that question. We'll have him back on for that. So thanks, Eric. MCR engines. Darren, I remember you said the worst thing is to plunge a 90-degree cutter for the throat ID to set the throat percentage. If you have some to remove, how do you do so? 85 degree?
Yeah, about an 82 on high-speed NA engines. It'll be about 80, 82 would be the steepest I'll go, and then come right off into the back wall. But boring the throat, again, production cylinder heads, they have to do that.
Right.
That's consistent, it functions decent, but when you're trying to shove the engine efficiency, speeds, and produce more power, it gets detrimental.
Michael asks, does using lower RPM on the valve job machine help control heat on the seat and wear on the cutter?
The heat's not a factor, but it definitely helps control chatter, vibration, and it can get it more concentric. Like a 30 at 20 RPM, I mean, you could spray it and walk away and just let it sit there and dust. Just so long as you keep seeing it dust, just barely shaving it off, you just let it do it until it's done. And sometimes that could take a minute, you know. But that's another half thousandths better concentricity.
Chris asks, any tips for porting a Hemi? And do you know anything about the BES Hemi that won the Engine Masters?
No, I don't know anything about that thing.
Okay.
That was all Preston and Tony.
Any tips on porting a Hemi?
Well, the short side is not critical on the Hemi. As a matter of fact, you can lay that short side back an extreme amount, because just like a valve that's close to the bore wall on like a wedge, the valve is closest to the bore wall on the short side. So you don't want to turn the air into the bore wall. So the Hemi port comes in like this, like that, and the bore wall is right there. So the last thing you want to do is come in here and try to turn into the wall. You can develop the port to where on a super stock Hemi, I'll show you what it looks like. There's the valve. I would say it comes in just like that.
Wow.
There's almost no short side because the bore wall's right there. So as that valve opens, the pressure recovery is perfect. So that valve's open, the air will conform right down the bore wall. So you need almost no short side at all.
You went out. So Turner asks, ED5 is denser than gas, but also heavier. Does small block Chevy carb intakes need to be on the small side?
I thought E85 had a lower specific gravity, not a higher one.
And then, oh, here's part 2 of his question. And then he says, to keep the velocity up for heavy E85 fuel.
I'm not following there.
I mean, what he's saying is E85 is heavier than fuel or gas. So do you
okay. The fuel density due to the volume ratio. Yeah, okay, I got you. The specific gravity is lower, but you're putting 1.6 times more volume through the. Okay, yeah, I get you.
Yep.
Yeah, if you just keep the ports the same size as you would for any other fuel, you're fine. You do not need to make them bigger. You don't need to make them smaller either. I don't think. Now, see, this is an area that I haven't done any testing in, so I'm speculating there.
Okay.
Maybe, I don't know. I don't know that one.
Here's kind of an interesting thing. Bob says, hey, Darin and Tim, I have made a custom 6-cylinder Cleveland-style cylinder head out of 3 heads for my 310 cubic inch 6-cylinder. Is that something you'd be interested in working on?
Yeah. Hell yeah.
Call Tony, talk to Tony at BS and see what he has to say, Bob.
I'm doing a cylinder head for a Jeep right now. That's 25%. Let's put it this way. There's 4 pounds of rod in this head.
Jesus.
I literally pre-warped it. I would weld on the top and the whole head would bow up.
Yeah.
And I flip it and weld on the bottom and it would bow up the other way. The whole head shrunk 35 thousandths in length.
Wow.
So had to completely remachine everything.
I'll tell you, Bob, I have one of those cylinder heads sitting over in the corner. That was my plan one day, is to build a 6-cylinder Cleveland. So good luck. Talk to Tony. He'll see what he can do for you. Extreme Performance says, off the OD of the seat leading to the chamber is almost flat before it gets to the angle of the chamber wall. Do you remember that?
Yeah.
Do you know what he's talking about? Okay.
Yeah, so it just comes straight out, straight up. Yeah, a radius there will help, is better.
Okay. And Kid says, hey, yes, Goodson makes the 3D fast cut setup. Just wondering if
these cutters, all these cutters will fit the 3D fast system.
Perfect. And then he mentions, hey, YouTube Premium, there's no ads if you guys want to go that route. Not sure says, question, do you have a throat percentage rule or suggestion for 4-valve exhaust ports?
Again, that's situation dependent. It depends on whether it's NA or power adder turbo especially. The turbo stuff, I don't make things big. As a matter of fact, some of the 2JZ stuff, the exhaust ports were just polished, keep the exhaust gas velocity high, so it spools the turbo. But for an NA deal, depends on how high the engine speed is, how much you are up against that valve. I mean, if it's a lower RPM range deal, you would be smaller than a high RPM range. So I would have to know what you're doing, the engine combination, and everything else to answer that question. It's engine and situation specific.
All right, there you go. Thank you. Jeff says, Darin, have you found any applications where increased exhaust valve size and flow was an advantage for decreasing exhaust duration?
Yeah. Yes.
Okay. If you want more guide to wall clearance on the cylinder wall side, bias 2 valve. I guess I'm not, he asked the
Yeah.
question about the 4 valve percentage rule on the exhaust.
Oh,
So,
in other words, would you offset the throat in a 4 valve? Yeah, absolutely. Absolutely. As a matter of fact, in the center, all the airflow is basically between the 2 valves, so you would have almost no angles there as opposed to the outside. On the intake as well.
now here's a comment from Jeff. He's an LS racer. What's he say? The BTR canted valve LS heads are designed for stock type rocker arms and individual mount pedestals that limit lift to 720. FYI.
Which is a lot of lift for heads you're going to use for high performance street use.
Yeah. Pontiac 411 says, I find if you measure from the valve stem to the bowl wall, that the bowls as cast are not the same from bowl to bowl due to core shift.
Oh, okay. Yeah, absolutely.
You know what I'm
yeah.
saying? Yeah.
They're all over the place sometimes.
Right.
Yeah.
So that's what he's saying.
Yeah,
You
so-
measure it to start with before you start porting, so you know
Oh, yeah.
concentric and not getting the
Absolutely,
water
yes.
somewhere. Okay. Now here's a good one. Approaching 2 hours of great experience and being shared. And we appreciate you guys being here. I told Darin we're going to try to limit it to 2 hours. It's already 2 minutes past that. I'm just going to kind of run down through here and see what else is going on. It's just a matter of trying to not be here all night and answer everybody's questions. You know, Blitz says, how large can a valve be before the remaining valve seat surface becomes insufficient for reliable street strip application? Is there a general rule of thumb for determining the maximum valve size?
Yes, there is a general rule of thumb, multiple rules for determining the maximum valve size. First and foremost would be the bore. So you're going to shoot for a wedge head. The valve's going to be 50 to 51.5% of the bore. For a canted valve, you could shove it up to 54.5%. But the question is, do you need that much valve? How much air does the engine require to produce the power in the RPM range that you need? That's the second rule. So, yeah.
Okay.
How big can it be? See, how large can a valve be before the remaining valve seat surface becomes insufficient? Oh boy. That's situation engine specific. Yeah, that's street strip applications. It depends. that's
Okay. Now this question, I kind of saw this on some heads in Facebook where it looked like the dividing wall, like on a small block Chevy, was cut way back. And it says, Darin, have you ever removed the dividing wall between intake ports up to the head bolt hole? Did you ever see any gains?
on supercharged applications where area is greatly needed and you have no harmonic content in the manifold because it's supercharged and the runners are non-existent, then yes, it can make more power doing that. For an NA application, it's a complete and total disaster.
Reversion City is what I saw.
Oh, yeah.
Yeah.
The intake port looked like the exhaust port. It's
Yeah.
got so much exhaust gas recirculation.
Yep. Redneck says, I got a random question that I think you have touched on. Short, wide ports or tall, narrow ports? Why block Ford style or cathedral port style?
I'm not sure I understand the
Yeah.
point of the question.
I mean, if you just look at the first part, are short, wide ports better than a tall, narrow port? Like short, tall, narrow, LS
Yes.
cathedral port versus like a short, wide, whatever.
Yeah, they are.
Tall, narrow.
The LS16 style cathedral port was designed so you could fit a tuned manifold underneath the hood of an F body. That's what it was designed for. It's that's its whole purpose and reason for existence. And the LS7 is actually a perfect example of how where the port should be and its shape to optimize the situation.
Now, here's an interesting one. Patrick says, "Hi, Darin. Thank you for doing what you do. I race vintage sport cars and have an MG Midget, which is a
Yeah.
5-port Siamese port head.
Done lots of those.
Any tips on porting and valve angles?"
Oh man, those things are so difficult. It's very difficult. They have no short side to turn near. And the harmonics are all screwed up in the intake manifold. So, yeah, there are lots of tricks. As a matter of fact, I think Vizard has documented most of them. Man, it's been 25 years since we did a lot of those about 25, 30 years ago. No, not really. I mean, that's a situation where 50-degree valve angles aren't going to help you. And that's one of the reasons Vizard was getting onto the 30-degree angles for those, because they're so low lift and you need to turn the air efficiently around the valve, and it's almost impossible to do because they have no short side, no bowl area, no any design characteristics that would allow you to do that. So it's compromise on top of compromise for those things.
All right, Patrick, thank you. Maybe check out David Vizard's channel, do a search on it for MG heads and see if you can find something. Mike Cranston from New Zealand says, "Darin, Harold Betts talked about Steve Zick's formula on flow testing carbs and being able to jet size the carb with this formula. Have you ever done this with results? Cheers, Mike."
No, I've never done that. I've never done that. I'm not a carburetor guy. You know, I don't design them. No, not the guy to ask.
There you go, Mike. Thanks. I appreciate you. Extreme Performance says, "Can you define a top cut for the 50 and 55-degree seat angles? Is it dependent on the chamber angle?"
It's not directly dependent on the chamber angle, but it can be influenced by the chamber angle. So the 10-degree less rule pretty much applies unless you just can't get that. If the chamber's too flat and all you can get is a 30, well, you got to go with a 30. But you should go with a 40 or a 45. But if you have to sink the valve in order to get that 40 or 45, now you have to weigh the compromise. Can you afford to do that? Can you afford that with the design changes, mill the head down? Can you afford that with the decrease in the short side area, moving the, yeah. That's a case of if the chamber is too steep, too flat, I mean, you're just going to have to get what you can get and deal with it.
Perfect. Well, we're going to do 2 more questions, and then we're calling it quits because it's past the time we said. So Racer X says, "Darin, what's your opinion? Single point Neuen versus multi-point, multi-angle insert SERDI to cut sharp changes between seat angles."
Well, there's nothing better than the new one. I mean, there's just nothing that can compare to it. The sharpness of the angles, I mean, just so long as you keep that tool, the insert absolutely sharp, it can have really well-defined sharp angles, better than a Surrey style cutter, single cutter. And it depends on who grinds those cutters. You know, you get a lazy guy on a Friday that doesn't constantly dress the wheel when he's cutting those to get a well-defined angle. I've actually gotten some and just sent them back because it was like, I can't use this at all.
Wow. Huh. Last question, and here it is. It says, this is J&S Marine Service. Big block Chevy made 1013 on gas. Changed over to alcohol carb, made 967. Any ideas on the loss?
Yeah, that's not uncommon at all. You're increasing the volume of fuel, the charge density goes way up, the harmonics change, you're going to lose 400 to 600 RPM on the horsepower peak. So if you lower your power band, that's an immediate loss in power. But you usually gain 40 to 50 foot-pounds of torque in that exchange. Now you would have to make cam changes, manifold changes, combustion chamber changes in order to move the power band back up to get that power back and hang on to that torque.
Okay. Well, there you go, guys. We're going to call it quits. It's already 8:12, and we both have some commitments to take care of. So we appreciate you being here for this open live chat, and we're going to schedule another one soon. I'll keep you posted on that. Pay attention to Darin's Facebook page. He's got some new things going on there, mine too, and the channel. I try to post things in the post sections of this channel because you're going to find a lot of announcements on there. You're going to see stuff that you won't see on a video. And that's how we kind of communicate with you when we're not through a video. So thanks, guys, for being here. We had at least 120 something people here. So that's pretty good. And it's on replay for the guys that want to watch it over again or have questions. Appreciate you being here. Thanks, guys.